let's learn about product and quotient rules. So let's say we have two functions, f of x and g of x. Well, the product of those functions, the derivative of the product of those functions, is going to be f prime of x, g of x, plus g prime of x, f of x. And we're not going to prove too many things in this class, but let's look at a proof of this one. So let's say we have j of x, which is equal to f of x, g of x. Then j prime of x is going to be equal to the limit as h goes to 0 of f of x plus h, g of x plus h, minus f of x, g of x, all over h. And now let's do some manipulations. Let's say this is equal to f of x plus h, g of x plus h, plus f of x, g of x plus h, x plus h, minus f of x, g of x plus h, minus f of x, g of x. So all I did is those two middle terms, we added and subtracted the same term. And now we can say that this is equal to f of x, g of x plus h, minus f of x, g of x, over h. Plus f of x plus h, g of x plus h, minus f of x, g of x plus h, all over h. And this is equal to f of x plus h minus f of x plus h minus f of x over h times g of x plus h, that's our second term, plus g of x plus h minus g of x over h times f of x. And g is continuous. G is a continuous function. We're taking the derivative of a continuous function. And so we can set h equal to 0 in our second term here. And so this is identically the first term, the first piece here is exactly f prime of x multiplied by g of x, plus, here we have g prime of x, I'm missing a parenthesis, times f of x. And that's our proof, but we don't have to worry about the proof. Once we know the rule, we can use the rule. So let's look at a function. Let's look at the function f of x equals x squared plus 2 times 3x squared minus 5x. Had to go back and fix that real quick because I was working with a problem where we had a cube in this third term and I wrote square. So fix that if you're working along with this. And so let's use our new product rule first. We have the f prime of x is equal to the derivative of the first, which is 2x plus 0, multiplied by the second, which is 3x cubed minus 5x, plus the derivative of the second, which is 9x squared minus 5, multiplied by the first, which is x squared plus 2. And now let's look at this. We have our product rule. We proved our product rule, but let's make sure it actually works. Let's multiply this out. And if I multiply this out, I get 6x to the fourth minus 10x squared plus 9x to the fourth, first, 9x to the fourth, second, plus 18x squared, first, minus 5x squared, second, minus 10. So in the end, we get f prime of x equals 15x to the fourth, minus 10x squared plus 18x squared, minus another 5x squared is going to just be plus 3x squared, and then minus 10 is going to be minus 10. So that's what we get as our derivative. Let's multiply the original function out and use the rules that we already knew worked. So let's say f of x is now equal to first times the first, which is 3x to the 5th power, first times the second, which is going to be minus 5x to the 3rd power, second times the first, which is going to be 2 times 3 is 6x to the 3rd, second times the last, which is going to be minus 10x. And let's take the derivative of this. Well, first of all, this is equal to 3x to the 5th plus x cubed minus 10x. And let's say f prime of x, after I multiply it out, is going to just be equal to 15x to the 4th plus 3x squared minus 10. And we see that we get the same answer. So our product rule definitely works. So now, maybe you should pause the video and try f of x. This is a different example. F of x is equal to 2x to the 5th times 4x squared plus x. Try to pause the video and take the derivative of this using our power rule. Now let's do it together. The derivative of the first is going to be 10x to the 4th multiplied by the second is 4x squared plus x. Derivative of the second is going to be 8x plus 1 multiplied by 2x to the 5th. And that's our derivative. Derivative of the first multiplied by the second, derivative of the second multiplied by the first. And that's our power rule. So now let's move into the quotient rule. And we'll start with an example that might surprise you. If I have x squared, the function x squared, f of x is x squared, then f prime of x is equal to 2x. We know that for a fact. But x squared is equal to x cubed over x. We all know that. We have 3 x's on top, 1 on the bottom, which means we just have 2 on top. But if that's f of x, if we have, let's say that's g of x, which is x cubed over x, g prime of x, if I wanted to just take the derivative of the top and the bottom, I would have on the top 3x squared, and on the bottom just 1, which is 3x squared. And we see g of x, g prime of x, is not equal to f prime of x. In this case, if I just do the quotient rule, if I just take the derivative of the top and the derivative of the bottom, I don't get the same thing. Because this is not how you do a quotient with derivatives. You cannot simply take the derivative of the top and the bottom. The quotient rule is a little more complicated than that. So the quotient rule, if I'm taking the derivative of a quotient, say I'm taking d dx of f of x over g of x, the derivative of this is going to be f prime of x times g of x minus f of x g prime of x over g of x squared. And this is pretty complicated. This is tough to remember. The way I like to remember it is here g of x is the low function, f of x is the high function. And so if I write it like this, we have the low function, g of x, multiplied by the derivative of the high function, minus the high function, multiplied by the derivative of the low function, all over the low function squared. We can come up with a little saying, a little rhyme to this, and not a rhyme, but a little way of remembering, which is low d high minus high d low over low low. So you can say that out loud if you're alone and not uncomfortable saying something out loud. Low d high minus high d low over low low. And what's nice about this is if you know the general structure, but you're not sure if you're writing it right, you can make a little boat with the L's. The L's should all be along the outside. So the quotient rule is low d high minus high d low over low low. So let's do an example. let's say k of x is equal to 5x squared over 4x plus 3. Then k prime of x is going to be low d high, which is 4x plus 3, times the derivative of high, which is 10x, minus high d low, which is 5x squared, times the derivative of the bottom, which in this case is just 4, all over low low, which is 4x plus 3 squared. And we can do a little simplifying. I can multiply the top out, and I can say, okay, this is 40x squared plus 30x minus 20x squared, all over 4x plus 3 squared, which is equivalent to, we have the x's that can cancel, 20x squared plus 30x over 4x plus 3 squared. And so we can do a little bit of simplifying, but chances are we're not going to be able to cancel anything with the top and the bottom. So that's our quotient rule. So we'll do one more example in the video, and then you'll do plenty of examples separately. Let's say I have f of x equals 3x plus 1 over 4x minus 3, and I want to find f prime. Well, I know that my saying is low d high minus high d low over low low. I make sure I can make my little boat with the L's. I make sure the L's are all along the outside. And then I just plug in. I say the low function is 4x minus 3. The derivative of the high function is 3, minus the high function is 3x plus 1. The derivative of the low function is just 4, all over low low, which is 4x minus 3 squared. From here, I can do some simplifying. This is f prime of x. From here, I can do some simplifying. I can multiply it out. I can say this is 12x minus 9 minus 12x minus 4, all over 4x minus 3 squared, which is equal to, you see the 12x's cancel, negative 9 minus 4 is negative 13 over 4x minus 3 squared. And that's really it. That's the quotient rule. I suggest doing a bunch of practice problems just so that you ingrain in your head the formula. You can either learn the actual formula, which is right here, or you can remember low d high minus high d low over low low.